Welcome to Let's Roger That, everyone. My name is Gilles, and today we're going to make an outside diameter grinding fixture for my surface grinder. Why do I need that? Well, I've got a whole bunch of these stainless steel bars, and I need to make sure they're absolutely straight. And that's the only way to do it. So let's get to it. So this is an outside diameter grinding fixture. I don't think I can say that 4 times in a row real fast. But essentially what it consists of is primarily 2 spindles in which a piece of round stock is held and then spins while the surface grinder goes from one side to the next and makes it totally concentric. Here, okay, so let's go through the basic parts. You've got a base on which the tailstock and the headstock sit in, held by a T-nut, and they can slide back and forth in order to match the size of your stock. Dresser here, that'll be a nice addition. Here we have a stepper motor, and I'm going to use that to drive the whole thing with a timing belt so there's no slippage. In here is going to be the driver and control circuit. So next step is to actually start squaring up these pieces and go to town making it. All right, so we're gonna put a fly cutter across its surface, flip it over, do the same thing, and then we'll square the ends, etc. All right, that's good. So now I'm at the surface grinder, and you're wondering why I'm putting the cart before the horses. I'm working on this base, and this surface and the bottom surface need to be absolutely parallel. All right, this is side 1, and that took an hour and a half. No wonder they charge about $8,000 for one of those Herrig OD grinder fixture. All right, so this is after surface grinding the edges. And other than a few tenths, up to 5 in places, this is well within my tolerances. So in places like where there might be slight imperfections, we might be up to 1,000ths, but the overall surface is flat. So flat enough for this kit. All right. Okay, so one of the things that are really important to measure here is that this part is square. It's really nice to know that this is flat, both sides, but if it's not square, we need to fix that right now. To do that, to measure the squareness, you turn the surface gauge into a squareness indicator, and you take something that you know is square, like in the case of this angle plate, and you come in and we'll set this to 0 So at the high spot, should say 0. I'm just gonna tweak it. All right, so that's my 0. That's lovely. Now, what I need to check here, this is flat, this is flat, or this is flat here. So I need to check that all this is flat or square. So we'll come into it. And my indicator says, of course you can't see that, so you have to trust me somehow, 5.5 thousandths plus, which means this is leaning this way, right? So if you're looking at a square, it's leaning this way. So that's not good. And I've already checked along the whole thing. It checks in at that. So that means, quite truthfully, let me just put this like that so you can see that this corner is high and this corner is high. So we're tilted, makes complete sense. So now when we have to go to the mill. We're gonna shave off, go in, say 2.5 or 5 thousandths on this side until and then we'll come back and we'll check to see if it fixes squareness when it comes to this angle here. Making precision parts is always a very big challenge, especially when you set unrealistic goals like I am doing now. Okay, so I'm back at the mill, and what I want to do, of course, is square the sides. I've trimmed my vise within 1/1000 of an inch. So that's as best as I could get right now. So I'm gonna bring my end mill and I'm gonna square this like the gentleman at Suburban Tools. So these need to be squared as well. I'm gonna square this way, square that way, come back this way, all around, and then I'm gonna flip the part and move on from there. It's hopefully, fingers crossed, it'll work out. All right, something else that's, I guess, important to mention is that I've taken the time to measure the distance from here to here and here to here on both corners, given that this surface is flat. I just wanted to make sure that that was gonna be okay. Okay, gone all around. So now I'm going to clean all these edges and flip it and then do the same thing again. Now, because these are nice straight edges now, I won't need to have that little piece of wire of copper to compensate. So let's do that. Okay, so just to measure the height, making sure that this is flat across the board, I've taken a depth gauge and using a 1, 2, 3 block, I'm all the way around at 2 inches, or let's call it 4 inches, 609 with a 2 to 3/10 variance. That's pretty good. So now we'll do the whole round the clock thing again and get the two sides squared up, and then we'll go back to the surface plate and verify all that stuff. I know this side wasn't square either, so I figured out that this is the high side. Okay, we'll give it a check with a little square. Good start. Clean it up. Feels good. Oh, we've got a burr here. Nice. Okay. And that was a huge ordeal to be able to be perpendicular, and this surface here is flat in under 5/10 of 1/1000 of an inch. So that is exactly what I needed, because I'm going to put this edge on the fence of my surface grinder. Now, this T-slot cutter is going to be used in order to make a T-slot going all the way along here. The critical part of this, if I may, now this is where it's important to know your stuff. So you don't want the headstock or the tailstock, which is going to move, to not be aligned at any time. So therefore, when you move the tailstock back and forth to get the distance you want for your part, then you want this to be a location clearance fit. And if you look in the machinery's handbook, you'll see that on in the area of page 637. So that's what I chose to go with. So basically a tolerance is going to be 1.6 thousandths, okay, 1/1000 and 6/10. So not a lot of room for error for this area here, and that'll create an appropriate location clearance fit. Now that the base is cut, it's really important to mention that the tension in the metal and widened the top of it when I cut the T-slot. As a result, there's a change in size. See, 39665, and at the top I'm at 3971. So that's going to cause a bit of a bow in the top, and I'll have to grind that down at some point during this project. Now I'm at the drafting table, and I'm having to revise some of my calculations just because while I was machining everything, I didn't quite achieve the same measurements that I thought I would. Plus, I made additional changes as a result. So now I have to start working on the tailstock and the headstock, and those are some of the measurements that are involved. I'll be making all of these diagrams available to you on my Google Drive. So next, let's square the pieces for the headstock and tailstock and get them ready for us to start putting in some of their features. Now it's time to start cutting holes for our spindles. I've aligned and measured everything with edge finders, and note that of course the spindles have to be perfectly aligned as much as possible, and therefore that is why I'm using an end mill. Before I mill this out for the motor, let me show you the motor that's going to go in there. And this is the orientation in which it will go. Now it's the cavity is going to be 1 inch 700 thousandths square. All right. So let's go to the milling machine and do that. I'm now ready to cut that groove, that 1/4 inch groove that's going to be here for the motor mount. And I've got a 1/4 inch carbide end mill that I'm running fairly fast. I'm going to go 1 inch 950 thousandths this way, and then we're going to come this way. That way I'm conventional milling. Let's do it. Just creeping in on the correct measurement. Excellent. That's the first pass done. Now I'm going to use a 1/8 end mill in order to make that corner as square as possible in order to get the motor mount plate to sit in there and have as much steel to grab on as possible for the threads. Let's have a look at this thing. Looks good to me. All right, the drilling is done. Now it's time to take care of that feature at the bottom of the headstock and tailstock. All right, I've got the bottom features cut, milled on the headstock and the tailstock. So let's try them on. Tailstock. Nice. That's amazing. All right, headstock. Perfect. This is really great. Now, I can see here that there's an issue with the unit going like this, and the same with the other one. See that? So I presume that this might be caused by when I cut the slot, the metal expanded like this, right? So I might have a bump here, and I could probably correct that quite easily with the surface grinder. And since I'm going to go there, I'll flatten these parts here on their side as well. Might as well make it all flat. But there's no rush to do this. Now I need to make the motor mount plate. So that's where I'm going to go.